Welcome to a new test and teardown video. Look at this big unit. It is, I think, like a cassette unit for plug-in modules, and I think it's all from NF Electronic Instruments. It can also be NF Corporation or some stuff like that. I think it's the same company, because when I Google NF Electronic Instruments and search for P61 Differential Amplifier, I find a Valuetronic website, and they show a little bit about the specifications and stuff like that. So this is definitely an audio range, and this unit consists of a 2 input amplifiers, or like 2 differential amplifiers, like you see here and here, and they're called P61. And as I said, it's a differential amplifier, so this means it got 2 inputs, and the difference between the inputs is the signal that gets amplified. So you can change the gain 1, 2, 5, 10, and then a multiplier of 1, 10, and 100. So that means 100 times 10 is 1000. Can you imagine that will be a little bit of millivolts, gets up to a lot, right? So the output here from the differential amplifier is obviously a single-ended output, and this output you can connect to the input of a filter 1 and 2. So this is the plus-minus input for amplifier 2, and this is the plus-minus input for amplifier 1. And then the 2 filters, they're called P84. This is, what are they? 48 dB octave. Look at the cutoff frequency. It goes from, it's difficult to hold like this, 1 to 16, and then a multiplier. So it could be 1 to 16 hertz, 10, 100, or kilohertz. So all the way from 1 hertz to 16 kilohertz. So that is the cutoff frequency you can select for this filter. See here you can say, is it low pass or is it high pass, or is it through? And I think the filter got no gain, so that means you'll trim on this trimmer for no gain in the filter, because you don't want that to be a gain stage, you want the gain part to be the gain. I really hope this works, because there are like a million cool things we can use this cool box for. It is very big and very heavy. Let me swap it around so we can see. Oh yes, there's one more cool thing. Look at this. The on-off switch. This looks a lot like old Tektronix scopes. Yeah, this is exactly where you have seen this before. The back side here could have been made a little bit more beautiful. I don't know exactly about all those cables like this. Very long and just sticking out of the back like that. I would probably have made it a lot shorter, because this is really not my style. Cascade, and floating ground. So this will be the input to your filters, and this is the inputs to the amplifiers. Oh yeah, it actually says a little bit here as well. 100 mega ohm, 50 picofarad. So it's very useful for super high impedance kind of experiments. There's also a little output here. Yeah, the power supply unit is inside this case is a model MS523, and it offers two different options, AC input or DC input, and here you just input your 12 volt DC. Obviously, if you want something with very, very high gain and ultra low noise and stuff, you could just run this off a DC battery supply, and not being connected to the mains will obviously give you less noise, no matter how good you are to make power supplies, right? I'm a little bit worried about this detail. AC 100 volts. Is this minimum or is it maximum, or is it adjusted for USA voltage? You know what I mean? So I can't just plug this in, or maybe I should just see if I can find a manual, the MS523, and it says I need to look this up, otherwise I have to pull this thing apart. I did a little bit of looking in here just to sneak peek of the amplifier. Whoa, this is some sexy stuff, beautiful stuff. But we are going to test, and we're definitely going to look a lot more in detail what we got here. This is some kind of quality, that is for sure. Look what I found. I just went to NF Corp website and got the manual for this 523 plug-in, or the power supply, and look what it says here. So the 523 is what we got, right? And it is powerful 12 volt DC source in addition to 100 volt AC. And the 525, this is not what we got, is powerful from AC line of 100, 200, la 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 la. So that means the unit we got is only 100 volt AC. That means my unit is definitely blown up, because some muppet definitely plugged this into normal mains here, and we got 230 volts. So I need to check out the power supply before I do anything. And it continues on the next page. Power supply, the 523 model, AC mode, see here, 100 volts plus minus 10%, not plus minus 200% is what I need. Damn it. Let's just do this always. Power on. We're going to crank up the voltage to 100 because we want to see how this runs at 100. Let's pull. Ooh, there's a fan. 40 watts. Okay. So far so good. I don't see any LEDs or anything fancy-pantsy. I would have loved some test points or some voltages, LEDs on one of those blanks. Why didn't they put this on the mainframe power slots for the other? That is a little bit stupid. That could have been a super good idea. So how do I know if this is working? Yeah, let's put in some signals and see some stuff. Okay, gain 1. 1, 1, 1. And what is this? Measure or ground? So we can enable. What can we do here? Measure or ground. One of the inputs, I guess. So we can make it single-ended. Oh yeah? So that's what we do. Definitely a good idea to try this. And we are back in business. It really works. At least I'm just testing the first input amplifier here, the differential amplifier. As you see here, we got a little bit of hum. It's jumping a little bit. It's because I got both of the inputs open. What I can do is I can just short circuit the negative input. So now I'm only using the positive input, if I kill the positive input, I kill my output. So this is in gain 1 and multiplier 1. I got 100 millivolt peak input, and obviously I got 100 millivolt peak output. Fantastic. So it really does work. What if I gain it 2 times, 5 times? Isn't that just amazing? Of course it works. This is quality stuff. Times 10. Okay. We need to crank down. So this is, again, see? Now we got 1 volt per division. And this is, of course, 10 times the 100 millivolts of input. So what if I take 10 times 10? Now we got 10 volt per division. It really works. Is it possible to do? Oh, no. What if I go this? Yes, I can do 100. So that is, of course, 10 volts. Again, because 10 times 10 is also 100. Aha, see? So that is, here we go. 10 times 10 is this. Oh, this is a little bit confusing. So this is 10 times 10 or 100. How about 200? How about, okay. I am totally happy about this. Wow, how cool is this? This is super useful. Now I am dying to see the filter system here, how that works. Definitely we're gonna play with that one now. So okay, we still continue to use the amplifier. 10 times 10, yips. How about we perform a little bit of a frequency sweep on the differential amplifier first, before we start to play with the filters. So this way we know if this stuff is working. Yeah, that's a good idea. I've been playing a little bit more with all the frequencies and stuff. So this is actually 100 kilohertz, and I can now barely see the amplitude is a little bit down, and I'm still in 100 times amplification. Obviously, I expect it to be better if I don't have any amplification, but I want to test this with a lot of amplification, right? So, and it is specified to 100 kilohertz, and let's try and crank up the 200. Ooh, so yeah, okay. So it's 300 kilohertz. I guess the 300 kilohertz is the minus 3 dB point. So that, let's go the other way down and see when is this. This was 1 kilohertz again, and the instability we see here, that is definitely because of the power supply or some internal noise, or the switch mode that is going on in here is affecting something. You can see there's some nasty stuff going on here. Even if I turn off the, yes, there's definitely a little bit of stuff going on. So this was 1 kilohertz, 100 hertz. Let's go back again. Aha, that is interesting. So this is 100 hertz, and what have we got here? Can you see there's some stuff that is rolling slowly here, and this is obviously mains that is interfering, because if I change the frequency to 100 and see 99 hertz, haha, now you see the instability. That is funny. Now it's a 1 hertz thing. So this is the interference with the mains. Let's go back to 100. Let's crank the frequency down to, ooh, nasty, right? Rectifier current spikes. That is what it is. Look at that. The spikes like this, rectifying diodes directly into capacitors is what causes this normally. And you will see those spikes. So this is 10 hertz. And that is exactly why we get That is not supposed to look like this. I am sure this can't be good. And this you could hear if I put a loudspeaker on this now. You can imagine this is a very, very low bass, and then we have this 100 hertz nasty stuff on top of it. But still, we have exactly the correct amplitude, and this is yeah, like I said, 10 hertz. Let's go all the way down to 1. Oy. Still the same amplitude at 1 hertz. Oy, that is really, really cool. And I think it was actually going all the way to DC. That is what it was. This amplifier can actually go all the way to DC, and I have an idea. Let's test that. How about we just? I think I am actually in. Yes, I am definitely in DC mode. So how about I just play with that for a second. So now we can play with a little bit of DC offset. That was me causing DC offset on the input. Look what I'm doing here. I'm putting DC offset on my signal generator because, yeah, of course I can do that, right? Just go down. And so that means my output follows the input, of course, all the way to 0 hertz. That is very, very useful for all sorts of science experiments. What a great amplifier. I just need to fix this noise problem, definitely. Of course, I'm going to repeat all the tests here on the other amplifier, and then I'll play with the filters. I think this is our lucky day today. High pass and low pass filters, they also work. So what I found out here is there's a through and MF. I don't know exactly what that means, but I think we go through the filter section, but it's not doing anything really. And then we got the low pass and the high pass things, because it just don't do anything. Oh, there's a little bit of loosey juicy here in this connection here. It was not at all like that with the other one here. See, I just need to exercise this a little bit. But in the high pass version here, 100 multiplier, that means here the 10 here is 1 kilohertz, and this is our input is 1 kilohertz. So let's see what happens. Ooh, look at that. And then it goes slow, right? How about I just put this at 1 kilohertz, and then we dial on the input frequency. So this is 1 kilohertz input. Now I go to 100 hertz step. So low. I'm in high pass. That means I need to be, this is 1 kilohertz, and then this is 2 kilohertz, right? 3, 4, 5, and so on. And we go down to 1 kilohertz again, and it's a little bit, this is the cut point, so this is the 3 dB point. And then we go a little bit down. Ooh, this is only 900, 800, 700, 600 hertz, and it's just gone, right? So of course this filter is very, very effective due to a 48 dB octave. Very, very fantastic. Very useful for all sorts of experiments. Especially you can cascade these through things, so you can have high pass and low pass combined. So you can have a band pass filter again. So this is what I really like about this unit. But now I really would like to see what is inside. And it's also a little bit annoying. I need to supply this with 100 volts AC. I don't know if I like that. So this is the inside of the differential amplifier. This will be the 2 inputs. And see, the connectors, they are not connected to the chassis. it's isolated. I don't know exactly about this very long connection to the shield, but okay, this thing is only specified for 100 kilohertz, but maybe I expected this to be a little bit shorter. But anyway, so the two inputs goes to the input selector. So this is where you select the positive and negative inputs to be either in or out, and then we got those field effect transistor amplifiers, and then a dual MOSFET and another dual gate MOSFET, or you know, a MOSFET pair, right? And then we got some relays, some more op amps, and or maybe those will be integrated FETs or transistors. We got more FETs, and see, all this is high precision resistors, the red ones here as well. So all you see here is high quality parts, and it's just, now we're in the transistor land, and then output, power output amplifier. So this thing can drive quite a high voltage into a very low load. There's of course also a digital interface, because this one can be remote. I think it's IEEE and all that kind of fantastic stuff. So all this will be a remote interface, a digital interface, to handle all the different settings, gain settings and whatnot. So all the different gain things goes via all those things, so it can be remoted as well. Extra power supplies here. It is really, really beautiful design. I really, really like it. They know what they're doing. Let's look at the filter section. Oh yeah. See this really nice locking. Oh yeah. Good shield. Yeah. And this is the filter unit. So the input, you can select if you want cascade, float, or ground the input. And again, I'm not really surprised about the design here. We got a digital interface for the remote control system, and that will be the different filter switches. So all this is of course done by switches. Cutoff frequency, multiplier, and low pass, high pass stuff is selected here. So here's how I think this thing works. If you look at all the different ICs, you see analog multiplexers. You probably heard about these. 4052 and 4066, very, very famous analog multiplexers or analog switches. And all we see here is op amp and filter sections. So of course by selecting these things, we just select in and out of this and this and that. And again the same output power amplifier, so it can deliver quite a lot of power into low impedance load. And this is the output, and a little filter inductor. Yeah, beautiful designed, nice, I love it. And the only problem I found was a little bit of a buggy with these switches. I don't know exactly this brand. I just think we need to massage them a lot, and then it's probably gonna work just fine again. So this is all the modules out, Ooh, there's a little funny detail. One of the modules needs to be another type, because look at that, connector is not in phase, not the same height. That is funny. Let's see if we can get into the power supply. Oh, and by the way, what they have done here, those are just blinds. You just lift them up like that. They are not mounted in any way. So this also means the B and C connectors, they connected to the back of all the different units. All you have to do is pull a little bit and then it goes loose. I think this is not super ideal. What they should have done is should have taken a little piece of metal here and screwed this a little bit smarter, right? See? Yeah. It was really easy to open this with this size, so it just slides out. Here we can see it much better. Shielded cables for all the different analog input outputs that is on this external jack. And we got a really funny fan in here. And we got some adjustments for the 5 volts and the 24 volts. This is explained in the manual. Got a very big transformator in here, a relay, and this is exactly what I was afraid of. See, it's only a 180 volt capacitor, and this is of course rectifying the 100 volts we get in. And this is why this unit is indeed a 100 volt plus minus 10%, as it says. I don't think we can get more in here, at least not easy. Ooh, there's a screw missing. No, it's right there. That is funny. So this one is longer. Aha. Oh yeah, there was one other thing I really liked here. See the transistors for the power supply? Can you feel this? This is like a hairy coating, or like cotton coating. So it is soft to touch. Isn't that just cute? Have you seen this before? Ah, nice. Always add very, very big and loud and clear warning information on products like this. Because we have 230 volts AC and it's the same connector. This is going to blow up one day if I didn't do this. Thank you for watching.